Hi, my name is Gavin Smith, and today I'm going to talk you through a short demonstration of the Voxon VX1 volumetric display. So let's get started. We'll turn on the VX1 and wait for Windows to boot up. After a few seconds, we'll put in our password and wait for the desktop to appear. We're going to now run VoxOS, our own volumetric file explorer, which is a bit like Windows Explorer. Lets you browse through the contents of your computer in a volumetric GUI. The screen is now running and displaying an animation file. So let's navigate through the folder structure and find a 3D file to look at. If we pick this skeleton file, it's a good way of showcasing the technology. I'm going to be using this 3D Space Navigator mouse to navigate the model, moving it around the volume, moving it up and down, and scaling it using the buttons on the side. This is a really good introduction to what the volumetric data looks like. You can pan the camera around or your viewpoint around and see that the display really is physically three-dimensional from absolutely any angle, and no special glasses are required. We can also support animations. They're simply a zip file full of objects, in this case an animated dancer which was animated using a motion capture file from Carnegie Mellon's online repository of motion capture files. These animations are merely a zip file containing a sequence of 3D objects that are animated, and like any 3D object, they can be zoomed, manipulated, panned and scaled on any axis. This next model is a three-dimensional fly. This was actually a hand-created 3D model. It really does give a very good indication of the level of detail that can be captured by a group of people gathered around the VX1. This one almost looks like an electron microscope image of a fly. You can zoom in to whatever level of detail was actually encoded in the model itself when it was created. And we've had groups of 10, 15 students gathered around the display looking at this kind of data. We bring up another animation file, and I'll show you some of the color features of the display. This one is a model of a 3D dragon. This was actually animated using a file from Mixamo, the character rigging company. So it came down as an FBX file which was animated in 3D Studio, and this one actually has a color texture map, so I can use the LCD screen on the front here and enable RGB mode, and that now renders it in color mode. As well as RGB color, we can actually choose any monochrome color if you want to see the data at its highest resolution. So any RGB plus the secondary colors. In fact, you can mix the colors in white mode to display any hue that you want to do. If we flip back to pure RGB mode for a second, we can show some of the other features of the VX1. In this case, we'll show you some gaming. Let's flick over to a game you might be familiar with. So in this game, rather than creating a line of blocks, we're actually creating a plane of blocks, a 3x6 plane. The blocks have to fit together. This one's very, very addictive. These games were actually created in C. This one here is another familiar game. We've taken an existing IP and made it much more fun by adding several levels to the maze. As an educational introduction to computer programming, students can edit a text file which describes the shape of the maze, and they can make their own mazes of any shape and complexity, and really have a lot of fun demonstrating them on their friends. Some files that we support natively in VoxOS are mol files, for example. This is a great way to look at chemistry data. This is a chess rendered in 2-color high-res mode, which we also use for DICOM viewing. This one's got a built-in AI. We've got some real flow liquid animation happening here, which is rendered in 3D Studio Max using the Real Flow plugin. This is a demo of Faceware face capture. And recently we've put a lot of effort into getting Unity running. We now have full support for Unity. This is a short demo using some sword fighting that we've created in Unity. The Unity SDK is available on our website. This is an STL file of a building showing how architectural data can be visualized by simply locking the rotation and moving the object up and down through the volume to see different floors. We've got our own mapping API, a program called MapView, which allows you to create geographical height maps from anywhere in the world. navigate through them and explore like Google Earth in 3D. This is a great example of stereophotogrammetry. And going back to education, this is one of our popular ones. This is GraphCut, which allows you to look at 3D mathematical formulas and a completely interactive way of typing in a formula and visualizing the shapes in 3D. You can create your own formulas or look at some of the 36 built-in formulas. And lastly, we'll wrap up this demo showing one of our new 3D asset types. This is DICOM. This is for viewing medical data. This is real-time marching cubes segmentation of data from MRI and CT scans. It's a very powerful way of looking at 3D medical data on the VX1. We hope you enjoyed that, and if you want any further information, please do not hesitate to contact us via our website. Thanks for watching.